Dr. Wininger received his master in biotechnology and a PhD in zoology from the University of Tennessee. He has been a laboratory director in Charlotte, Abington, Winston-Salem. He is now the lab director for Atlantic Reproductive Medicine Specialist in Raleigh. He also directs labs in Pittsburgh and Austin. Dr. Wininger research interests lies into the spent media research, specifically the blastocele fluid. And with this, I will let you, David, start your presentation. Thank you so much.
Thank you, Nabil, for inviting me for this. I'm going to be talking about the technique of trophectoderm biopsy and hatching at the time of biopsy. So this is a picture of a embryo that was hatched on day 3. This is an older picture, and as you can see, the majority of the embryo is hatched out, and you can see the ICM out there at about I don't know, 3 o'clock on the hatch part. So to me, that is one of the issues of hatching on day 3. So I'm going to be discussing the benefits of waiting to hatch at the actual time of biopsy. You call it hatch, it's actually a collapse. Okay, so this is the video of me doing a biopsy on day 5. I'll get it the light turned up here in a minute. And as you can see, it's an expanded blastocyst. I've got the ICM over near the holding pipette at 9 o'clock. And I set the laser at about 170 and put it right at the, just right at the outside of the zona. And you can see now it's collapsing. It's sort of, you kind of see a poof, the fluid of the blastocele is being released into the drop. That's an 8 microliter drop that I do the biopsy in, and I wait for the blastocyst to collapse completely. And you can see this is happening very quickly. And you can really see all the trophectoderm cells. You can see the ICM over there at 3 o'clock. And then I will be increasing when I start the biopsy procedure. Put the pipette into the hole that I made, the small hole. See, it comes off there. You have to get a hold of it good. I've set the laser at 470 for this part, and I kind of start pulling the trophectoderm. I really pull it and stretch it quite a bit before I do any lasering. I start pulling it into the pipette, and once I get a good piece and sort of stretch it thin, I start the laser procedure. You can see me laser there, and you'll see the whole blastocyst starts to come out. So I push it back in. That's one of that occurs no matter how small you make the hole. But so I keep laser a little bit more until the piece breaks free. And there it goes. Then I release it into the drop. Make sure I tuck the the blastocyst back into the zona. And I'll show you the picture of the piece that I took out. It's about eight cells. And as you saw, the blastocyst was completely collapsed. I wait till it really collapses almost down to what looks like a morula. And by doing this, I can put the pipette through the hole and pull a few cells out. And I don't laser until just the very end. And most of the time, it's just 4 or 5 shots to get the piece released. But I really like doing the biopsy at this point because the embryo is completely expanded. The zona is thin, and basically I'm just doing it's almost just like a collapse, like you're getting ready to vitrify the embryo. Without a biopsy, as before you do vitrification, you have to collapse the blast. That's basically what this is, except like I said, I set it at 170 and make a small hole. Sometimes you can actually make it smaller, but it's really easier to get the hatching or get the biopsy pipette inside the zona when you have the hole at about 170. Sometimes you have to aspirate a little fluid into the biopsy hole to actually it helps get the biopsy pipette into the zona to where you can get a hold of the blastocyst. Now, occasionally you will pull the blastocyst completely out, and you end up doing a zona-free trophectoderm biopsy, and that works fine. You just have to get the zona out of the way and get a hold of the collapsed blast and just go like you normally do. And then most of the time, I will just put the collapsed blastocyst back inside the zona because I think it's easier to keep up with, and I like doing vitrification when the zona is still around the embryo. Okay, I think we can go to the next slide. This is just another one that I had a video of, one that I had done previously, and it's the same thing. The blastocyst is collapsed, and I'm stretching. You see me stretching the cells into the biopsy pipette. See how thin the zona pellucida is. You generally don't see that as much when in the past when I did day 3 hatching before I started this. So now I'll start lasering at this point. This one probably starts coming out too, and you just keep firing a little bit. This is again at about 470. And these, of course, these blastocysts are completely collapsed, and they vitrify very well. The survival rate is excellent. And I think with doing it at this point, you get more cells, I think, from the trophectoderm because you're doing it at day 5 or day 6. I get a good biopsy piece, and that's about the same. That's 7 to 8 cells. So of course, either go to the next drop and do another one, or I move this to the embryo to a holding dish. I use a embryo corral dish or something similar that I'll put the blastocyst in, and or if I do, I've got a couple. I will move them. I'll have them numbered, 1 through whatever, and then I will load the biopsy pieces into the microfuge tubes with the small amount of media, and put them in the freezer. And then if I have another 2 or 3 to do, I'll go on to the next group. Okay, let's see what we have next. I think I have another. I don't know if it's the same one or another one. That may be it. I can't tell.
That's your last slide.
Okay. Okay.
Yeah.
All right. Well, again, I really like doing the biopsy at this point. I just think I think when you do the hatching on day 3, or some people do it on day 4, sometimes it's you do not know where the intercell mass is going to be. So at this point, when you're doing the biopsy, hatching at the time of biopsy, you definitely know where the ICM is. You can get it out of the way. Embryo is completely expanded, nice thin zona. It does not take much to do the collapse, and I just use regular size holding pipettes and biopsy needles. These are not small. I know there are some smaller biopsy needles, but these are just regular size biopsy needles, and holding pipettes as well. And I do not have, I think the smaller ones would probably be easier to get through the zona, but you have more danger of damaging the cells. So I use sort of a medium-sized biopsy pipette, same one that I've always used, and I never have any problem getting the biopsy pipette into the hole in the zona pellucida. So sometimes some of the issues that you run into with biopsies, whether you hatch on day 3 or day 5 or 6, sometimes the cells, the embryo may look totally normal, but the cells are very fragile. We see that occasionally, that when I start pulling the cells out of the zona pellucida, the cells sort of burst and break. And when that occurs, I usually, if I try it a couple of times and it continues, the cells continue to break. If it's day 5, I'll just put the embryo back in culture, try it again the next day, let it re-expand, and most of the time it works okay on day 6. I have taught my embryologists here to do biopsies this way, and there have been some challenges to getting them getting them to do it this way. I have one senior embryologist that caught on to it very quickly, but I just have to remind them to make sure that the blastocyst is totally collapsed. There have been, when they first started it, I'd watch them with practice blastocysts, some that with no, with poor trophectoderm, poor ICM, um, and they would get a hold of it and they would collapse or they would hatch, but they'd go right in and try to biopsy it before it completely collapsed. And when you do that, there's a lot of danger in injuring the blastocyst. So, so now they all wait, like I do, until it completely collapses before you do anything. Sometimes it takes, like this one, the first video I showed you, it collapsed in under 25 seconds. Sometimes it takes a little bit longer than that. Sometimes it may take a minute, minute and a half. But as I said, you can put your biopsy pipette right where the hole is that you made, and you can actually aspirate some fluid. You can blow a little bit of the media into the embryo, and things like that seem to help the embryo to collapse quicker. But I would say 80% of the time they collapse within 30 seconds. So I think that's a very important part of doing this. Another issue, as I've mentioned, is if you make the hole too big, you have a much more likelihood of pulling the blastocyst out of the zona pellucida. And even though you can easily do a biopsy with a hatched blastocyst, it's definitely preferable to keep it inside the zona. So you can play with the laser setting. As I said, I've gone from 150 to 170 to make that initial hole and collapse the blastocyst, and then I'll wait and then collapse it and start the biopsy procedure. But I do think that it does take practice. I would say practice with, like I said, poor quality blastocysts or 3PNs, things like that, 3PN blastocysts, to get used to it. First, practice collapsing it, which, if you vitrify, you know how to collapse, but you put your holding pipette on and your biopsy pipette and just wait for it to collapse and try it. But I do think you get more cells this way, and you don't have to worry about the ICM hatching out. One of the major times that it hatches out is when the embryo is already hatching. When you have a 4AB, 4BB, an embryo that is hatching out. So if you do have a large area of hatching, usually what I do is get a hold of the blastocyst somewhere else instead of trying to biopsy the part that's hatching. I will get a hold of the embryo somewhere else other than that, on the side, and make a hole somewhere else in the blastocyst in the zona pellucida, and try to keep the blastocyst in the zona, because if it's hatching out, 9 times out of 10 you're going to pull, if you just try to hatch it, but do the biopsy on the hatching part, you're going to pull it out of the zona. So usually I'll try to hatch somewhere else away from the hatching part and just do a biopsy somewhere totally separate. And I might laser or do a quick collapse of that hatching part to hopefully get it to draw back into the zona, but I'll get a hold of it somewhere else and hatch it again somewhere. And I think by doing that, you can keep the blastocyst inside the zona. Let's see if there's anything else here. Yeah, as I mentioned, I think it's important to, as you're pulling the trophectoderm, you want to do quite a bit of stretching and pulling the trophectoderm cells before you do any hatching. I like to, pull it out of the zona pellucida into the biopsy pipette before I do any lasering. So I don't want to start lasering right away. I think it's better to sort of stretch the cells and then hatch, or then laser at, like I said, at 470 before. Then I think you do, like I said, you do about 5 shots and it'll come right off. So do we want to do some questions now, or are we going to wait until we get to the next? You say after?
Yeah, we will keep the questions and the discussion at the end, the end of session number 6.
Okay.
I think we are ready to move to the next speaker. David, thank you so much for your presentation.